Beginner's Guide, Software Engineering Simplified. Ever wondered how your favorite apps and websites are built? Welcome to Software Engineering for Dummies. We're about to take a fascinating journey into the world of software engineering, breaking down complex concepts into simple, digestible pieces. Let's get started. Hey everyone, I'm Naim, and today we're diving into the basics of software engineering. This field is both an art and a science, involving creativity and technical skills to create the software we use every day. Ready to learn? Let's start by defining software engineering, the process of designing, building, and maintaining software. It's a structured approach that ensures the software we use is reliable, efficient, and meets user needs. Think of it as constructing a digital building. Why is software engineering crucial? It powers everything from your smartphone to space missions. Without it, our modern world would come to a standstill. Software engineers solve complex problems and create the tools that drive innovation and progress. First things first, coding. It's like learning a new language that computers understand. Just as we use words to communicate, coders use programming languages to instruct computers. Mastering coding is the foundation of becoming a proficient software engineer. Common programming languages include Python, Java, and C++. Python is known for its simplicity and readability, making it great for beginners. Java is widely used in enterprise applications. C++ is powerful and often used in system software and game development. The software development lifecycle begins with the planning phase. During this phase, developers gather and analyze requirements. This step is crucial to ensure the project goals are clearly defined and achievable. Effective planning sets the foundation for successful development. Next is the design phase, where the architecture of the software is created. This involves creating models and diagrams to outline how the system will function. Good design helps ensure the software will be scalable, efficient, and maintainable in the long run. The coding phase follows, where developers write the actual code. This is where the blueprint from the design phase is translated into executable programs. Coding requires knowledge of programming languages and problem-solving skills to implement the desired functionality accurately. After coding, the testing phase ensures the software works as intended. This involves running various tests to find and fix any bugs. Testing helps verify that the software meets the specified requirements and performs reliably under different conditions. After the coding phase, testing ensures the software works as intended. This crucial step identifies bugs and verifies functionality. By catching errors early, testing saves time and resources, ensuring a smooth user experience and reliable software performance. Agile methodology is a popular approach in software development. It focuses on iterative progress, allowing teams to adapt quickly to changes. Collaboration is key, with frequent communication and feedback loops ensuring that the project meets evolving requirements effectively. Version control tools like Git manage code changes efficiently. These tools track modifications, making it easy to revert to previous versions if needed. They facilitate collaborative work by allowing multiple developers to work on the same project without conflicts. Integrated development environments, or IDEs, streamline the coding process. Tools like Visual Studio Code offer features like syntax highlighting, code completion, and debugging tools. These features help developers write, test, and debug code more efficiently, enhancing productivity and code quality. Debugging is the process of identifying and fixing errors in the code. It involves running the software, finding the issues, and resolving them. Effective debugging ensures that the software runs smoothly, providing a seamless experience for users and reducing potential problems. Debugging involves locating and fixing errors in code to ensure smooth functionality. It's a critical step where developers use various tools to identify issues that could cause software to crash or behave unexpectedly, ensuring a seamless user experience. Software testing verifies that the software meets specified requirements and functions correctly. Different types include unit tests for individual components, integration tests for combined parts, and user acceptance tests to validate the overall user experience, ensuring reliability. Good documentation is key for maintaining and understanding software. It includes detailed explanations of code, architecture, and user guides. Proper documentation aids future developers in navigating the codebase and making necessary updates or improvements efficiently. Collaboration tools are essential for effective teamwork in software projects. Platforms like Slack facilitate communication, while tools like Jira help track project progress and manage tasks. These tools ensure that team members stay aligned and productive throughout the development process. Software engineering offers diverse career opportunities, from web development to data science and cybersecurity. Each path requires different skills and specializations, allowing individuals to find their niche and contribute to various technological advancements across industries. Books, online courses, and coding bootcamps offer excellent ways to learn software engineering. Books provide in-depth knowledge, while online courses offer flexibility and up-to-date content. Coding bootcamps provide immersive experiences, helping beginners transition to professional developers within a few months. If you found this video helpful, please like, share, and subscribe. Your support helps us create more beginner-friendly tech guides. Don't forget to leave a comment if you have any questions or topics you'd like us to cover. See you in the next episode of Software Engineering for Dummies. We're excited to continue this journey with you. Stay tuned for more insights, tips, and tutorials to help you master the basics and beyond in software engineering.